Please welcome Mark Scott.
Hi there. First off, I gotta say it's a little intimidating seeing everybody here. Not used to doing this very often, and I gotta point to my friend Mike Edelin. Stand up, Mike. So Mike is your new electrical safety program manager here. And this started off as, hey, do you want to give a short presentation to our management, to this all of a sudden. So I wasn't dressed for this or anything like that. Here we go. Again, my name is Mark. I am the program manager for electrical safety at Berkeley Lab. Been there since 2011. I guess I've been an electrical safety person for a long time because I always kind of cared about it. So this is my passion. Since it's my passion, I've been part of an organization called IEEE. That's the Institute for Electrical and Electronics Engineers. And they have a workshop every year called the Electrical Safety Workshop. I've been attending that every year since 2010. Most of what I've learned about electrical safety, I learned there and then kept trying to apply it on the job wherever I worked. There's two other co-authors for this. Ray Crow, who's been my mentor for electrical safety for the last 10, 12 years or so, and Danny Liggett, who's retired from DuPont. And we presented this in Reno back in January. So like I said, I attended my first workshop in Memphis in 2010. And one of the things that really struck me right off the bat was there seemed to be a mismatch. The mission statement said changing the electrical safety culture. And yet the people that were there, these were all of the electrical safety gurus that write these safety regulations, NFPA 70E. We all get training on 70E, but how often do we get training on electrical safety culture? So I was kind of puzzled by that, but it struck me, and I sort of made it my goal to always try to incorporate culture in how we train for electrical safety, because I just felt like it might have a bigger impact. So this year, we actually made a paper on it to try to really define what that meant. It's in our motto. So what does it really mean? And what is culture? So we look at a definition, and what is it? It's just a set of shared attitudes, shared values, the norms. It's the things that everybody just accepts as reasonable in everyday life. You see it, you expect it, it's okay. And that's just human nature. It's your set of common beliefs. So if you want to define a culture, roughly speaking, in an organization, your culture defines what norms you accept, but the converse is also true. If you look at what you accept, that tends to define what your culture is. So if we go from there, and we ask ourselves, what sort of things do we currently accept? And that's kind of the theme of this presentation. If you look back over time, what did we used to accept, what we don't accept anymore, and then asking ourselves, what are we going to do? So if we want to look at our culture, and if we want to change it, that means what? Redefining what we accept. So there was a paper put out about maybe 7 years ago by the two other co-authors, and it was called Beliefs Drive Behavior. And this presentation is sort of a continuation of that. Beliefs drive behavior sort of struck me as well. And it kind of had a few points that I'll summarize here. That if we want to reduce or prevent electrical injuries, we need to prevent or reduce unsafe behaviors. And related to that, we need to address what the beliefs are. If somebody doesn't believe it's the right thing to do, they're not going to do it. Doesn't matter what the rule says. If we look at safety efforts that are effective in organizations, where they have effective programs for safety, we realize that people have fundamental beliefs around those safety rules. And so if we want to influence that, people need to see a benefit around the safety requirement. Every organization I went to, whether it was the pulp and paper mills or the wind turbines or Berkeley Lab, that was one of the first barriers. People really didn't believe that there was a benefit to these safety rules. It's too stringent. They don't apply to what I'm doing. I'm more qualified than what you think, that sort of thing. It's always sort of the same story. So how do you change those beliefs? And the posit here is simply that if we want to change the beliefs in an organization, we have to attack the electrical safety culture. no matter where you're at. You could have a really good safety culture. Again, though, if you want to improve where you're at, that's where you really need to start. You need to look at how you can advance your culture, and that in turn will prevent your injuries. So let me give you a little bit of background. I'm going to try to explain and give some examples by showing some perspective here. So this clicker's a little sensitive. Where were we yesterday? In other words, if you look back 20, 30, 40 years, what sort of things did we used to accept? We just don't accept anymore. So these are types of designs called open bus, exposed bus, where people were actually expected to go up here and switch these levers. It's fully exposed voltage, 480 volts, 500 volts, that sort of thing. It was normal. It was built into the system. And believe it or not, there's still places I've been today that have these systems. They may have some screens around it or that sort of thing. I went to a factory in Sweden a couple years back, and they had rows of this stuff, and you had a narrow walkway in between, and you had to walk past it. It was a little scary. And I asked, is it live? Yeah, it's live. If you look at our work practices, these things are also acceptable. Testing voltage with your bare fingers, you've probably heard of that one, right? Performing live repair and installation used to be a basic job expectation for a working electrician. If you couldn't do this, you were out of a job. It wasn't just culturally accepted, it was expected. This is not that long ago. De-energizing without lockout, again. There are probably people in this room, this used to be your job expectation. This used to be a performance requirement for you. It looks silly now, but it wasn't silly back then. It was a day at the job. Back in 1953, the American Electrician's Handbook actually had, in their process, here's how you test for voltage. It wasn't just something passed down among the macho men of electrical. This was in the handbook. And it says, some men can endure the electrical shock that results without discomfort, whereas others cannot. This is a standard. So you laugh now, right? But this, I'm trying to illustrate how culture changes over time. What was acceptable before is not accepted today. So let me switch a little bit. And I'm going to show you where we were at 2012 to 2014 at Berkeley Lab. And this should look maybe a little similar. Here we go. This is a presentation, or a shorter version of a presentation I gave to all of our qualified electrical workers in 2014. And we had a string of incidents leading up to this. And I kept hearing, oh, it's not our group, it's the subcontractors. Or it's not us, it's those facilities guys. Or no, it's the researchers, they're not qualified to do what they're doing. And we graphed it out and we kind of showed that it was fairly evenly distributed. One thing to note is, when it comes to electrical, we have this thing called a safety triangle. And about 1 in 10 incidents will result in a serious injury, and 1 in 100 can result in a serious or fatality. You know those serious injuries here, we're talking about life-altering injuries, where people they're not able to continue their line of work. They have amputation, they have disfiguration. Had one guy in a turbine in Quebec got a shock at 36,000 volts in the back of the head and out the behind. He survived it, but he lost his ability for short-term memory. So 5 minutes later, you can't remember instructions. How well do you think that guy is able to perform as an electrical worker now? What do you think about his way of earning a living? This really can affect people. So here's a series of incidents. This one here, we cut into a live wire with a backhoe. Here was a researcher. They had a little heater block. It shorted to ground. And even though the system was supposedly grounded, the ground path was not valid. There was no GFCI either. Here's a subcontractor, was cutting, doing some demolition, decided to do a test just with a proximity tester, didn't do a live dead live, just cut it and it was still energized. So here's a person pulling a plug out of a relocatable power tap, got shocked. We've heard of these. Here's a plumber, got shocked at an improperly grounded light fixture, just felt a tingle. You know, we get shocked every day, right? We hear about these things, we see the ORPS reports, no big deal. Nobody was hurt. Here's a contractor who was tasked with cutting through a conduit. They had locked out all the circuits going through there, or they thought they did. In fact, the electrician had marked the conduit with the circuits. Circuit 1, Circuit 2, Circuit 3, and then a question mark. And what she said was, she thought there might be a second circuit in there, but to verify, she would need to separate out at the 10-foot mark, but they needed to cut out the drywall a little bit more, and she was told, no, we don't have time for that. 2 weeks later, when they implemented the Lotto, another electrician went there, saw the question mark, and asked for permission to go inside the panel to look to see if there was another circuit. He was told, no, we don't have time for that. So the contractor electrician said, okay, I know what to do. Put on a leather glove, take my hacksaw, good body positioning, zap. Again, no injury, no harm, no foul, right? This is what we were accepting. Until we had this. We had an apprentice electrician on a new construction building. Part of the building was already energized, and he was sent up to work and terminate some 277-volt wiring up in this junction box in the ceiling. This is at the top of a 3-story staircase. In fact, it was right up in here. Up on a ladder, top of a staircase, in the overhead. Journeyman sends him up there. No live, dead live check. Grabs the wire, strips it, and he gets hung up on it. And the way he described it was, I couldn't let go of the wire, and I couldn't let go of the ceiling. And I could feel it pulsing through my chest, and I couldn't stop it. That's as close as it gets. He survived it. We had a lot of issues with our emergency response. He didn't even go to the hospital the next day, and even then they sent him there in a taxi. So we had a little stand down, kind of like what we have here. And we look back at all our incidents and say, hey, we are not in control of our electrical work. We are accepting things that we should not be accepting. And it kept going. Servo motor. Here we were doing some testing and troubleshooting with this homemade jumper, sticking that into an Amphenol. This was in our nuclear sciences building. And somebody brushed up against it with their elbow. When we look at an electrical safety program that's not working, about 90% of electrical injuries you'll see are related to you're not locking out, or you're not testing before you touch, or a combination of both. And when you're doing testing and troubleshooting, you're really not controlling your work area. So just keep this in mind. I'm going to jump back to the main presentation now. Just wanted to give you a context. You know, Berkeley Lab, we're really not different than you. We had the same types of science, same types of people. So we started sending our people out for training. And a couple years ago, we sent our engineering division director out to this IEEE electrical safety training stuff for a week. And he learned about arc flash training. And he came back and he found out that we were having our scientists do Lotto. And this is a big magnet power supply for one of our cryogenic magnets. 1,000 amp, 480 volts on this breaker here. And this is where their walkout tagout point. And we found out they were switching this without PPE at almost 140 calories per centimeter squared. For those of you that don't know, this amount of energy, if this panel blows, will be enough to create a giant ball of fire in that building and probably kill the person. And they started asking themselves, is this the right thing to do? Should we be asking our scientists to switch breakers that have this level of hazard? without any training, without any PPE. Again, what were we accepting that we probably shouldn't accept anymore? Okay, here's a fancy quote here by Maya Angelou. She says, "You did then what you knew how to do, and when you knew better, you did better." So there's a learning process, but we have to change what we're doing. So where are we today? What do you currently define as acceptable work practices? I'm pretty sure there's nobody here who still goes around testing voltage with their fingers. From what I've seen of your electrical safety program, you require PPE for switching. You have arc-resistant switchgear. You have a lot of good stuff going on that we don't even have yet. If you look at the industry as a whole across America, there's a lot of things that came out in the last 10 years. You've heard maybe of the term NFPA 70E. That's the standard that drives electrical safety. You've seen people dressed up in these goofy suits to protect them from arc flash hazards. And we have a policy now where we really don't want to do energized electrical work anymore. We try to de-energize it if we're going to do repairs. We also have something called the hierarchy of controls. This is based out of a standard, an ANSI standard for occupational health and safety management systems. And it basically tells us that, guess what? PPE is the least effective method of control. Putting a worker into PPE and saying it's good enough when we could have engineered it out is not the right thing. In case you don't know, this hierarchy of controls is actually in 10 CFR 851, which guides what all DOE labs should be doing. We should always be looking at how do we engineer out the hazards. Here's an example of some arc-resistant switchgear. What it does, if there's a fault, it blows it out the top and redirects the flames away from the operator. One of the things about argon, you guys have been installing these for the last few years. Is Frank Perota in here? Frank? I can't see him, he's somewhere. He's not raising his hand. But he's the guy to thank for bringing this into the lab. Okay, where do we want to go tomorrow? In other words, are there things that we're currently accepting that maybe we should consider not accepting? And instead of telling you what you should or shouldn't be doing, I'm going to try to get you to think about maybe some methods to go after it, more of a process than a prescription. And this guy says, the difficulty is not in the new ideas. Everybody can have new ideas. But how do we convince ourselves to let go of the old ideas? And when should we? So I have 4 suggestions. I'll walk through this. The first one is why management should be owning the electrical safety culture. The second one is this notion of overcompliance. Third, how to incorporate this into an electrical safety program. And last, learning from human error. And there's probably more. These are just some things that we sort of came up with to try to help. Okay, management owns safety culture. We hear this all the time, right? Safety is everyone's responsibility. You are responsible for your own safety. Okay, yes. However, when you look at regulatory bodies, whether it's DOE or OSHA, if somebody gets hurt, who are they going to come after? They're going to come after management. Why? Because management sets performance expectations. And we talk about expectations, what we accept, guess what? That's culture. Do you see the link here between performance expectations and culture? I'm talking to the managers here. If you're a manager, you have a culture responsibility. Blaming a culture is not an excuse, especially if you're a manager, because you have a responsibility to take charge of that. Safety performance is no different than any other kind of performance. People want to know, what am I supposed to be doing? Are the requirements clearly defined? Can I access them? Are they understandable? How well am I required to do it? What do you think of my performance? As a supervisor, are you giving feedback to your employees on safety performance? Is that part of what you do? Are they going to be compensated, rewarded? Are they going to be, recognized for safety improvements? And are they going to be guided? How can I improve my performance? This is part of basic management. So you want to integrate that at all levels of your management system. Upper management, you need to show leadership. Supervisors have probably the most critical function. If you're a line supervisor, You get passed down all these policies and you're expected to implement them through your workers, and you never get any credit for it. I know that because I used to be one. And employees, they have to be kept involved, not just told what to do, but involved. What do you think is a better idea for how to do this? Is this an effective way to do it? Is this an efficient way to do it? Listen to them because they have the good ideas. We need to talk a little bit about consequences because there's a good way to do it and a wrong way to do it. If there's going to be consequences for poor safety practices, they have to be soon, certain, and positive. And what I mean by positive is there needs to be coaching. People need to understand that there's a better way to do it, why it's better, and how it's going to help them. Most importantly, though, no matter what happens, managers have the responsibility to reinforce the belief that electrical safety matters. You look back at the incidents that we were having at Berkeley Lab. There was a pattern there. People were doing things because they believed they were doing it the right way. Electrical safety really didn't matter that much. And that was one of the things we had to change. When we look at hierarchy of controls, who has the authority to implement that? Not the guy with the meter. They're already in the PPE. Who's the person who's going to engineer out the hazards? It's going to be engineering. Who's going to fund it? Senior management. How often does that happen? So if you look at what you accept today, start thinking about that. The myth of over-compliance. I don't know, I haven't heard that here, but I know I used to hear it a lot at Berkeley Lab. Oh, you're going too far. We don't want to be over-compliant. We don't need that. That's just too much. So what is that? So I'll just say it's a false notion right off the bat. It's the idea that if we are minimally compliant with regulations, that's going to keep people safe. And that if we add anything else beyond minimum compliance that's unnecessary, just slows things down, and we don't need it. Finally, people think, or managers think, that they have a responsibility to control costs, and especially safety costs. So they're going to kind of tamp down on this notion of overcompliance. So here's a little graph. This is how we process risk in general. And this is not specific to safety at all. If you look at risk over here, and sort of your risk control mechanism, the cost, right? If you have not a lot of controls over here, your total cost is going to go up because you have failures. Over here, your total cost is just going to be related to the controls themselves. And so there's a sweet spot down here. And there's this notion that compliance, just minimum compliance, is going to be right there. So you have your safety program manager. He always thinks you're over here. You're doing risky activities, you don't have the right controls. You have your project manager who thinks the safety guy is way out in left field trying to implement all kinds of stuff that are not necessary. Just kind of think of that as a perspective of when you have discussions about it. Just to give you an idea of what the real cost is of electrical injuries versus the cost of an electrical safety program. So these numbers here were pulled in part from my own experience at a few companies. I've had to implement electrical safety programs now 4 or 5 times, pretty much from scratch. If you look at the cost of implementing one, when you don't even have the PPE yet, you're looking at about $1 to $3 million for maybe 10,000 employees. Then you have a sustaining cost going after that. It's not a small chunk of change. But look at the cost of a serious electrical injury. The one that requires hospitalization in a burn center for 6 months with skin grafts. Or the one that creates a flash so big that it burns down a building. You're looking at 10 to 20 million and going up. Now compare those two costs. Is there a return on investment with a strong electrical safety program? There should be. Not only that, but how good does your program have to be? If I present one serious electrical injury, I've already paid for my electrical safety program. It's just common sense. Here's another look at compliance versus best practices. If you look at how these things are created, the regulations that we look at, so like the OSHA type regulations, they don't get updated but every maybe 20 years. In fact, recently the electrical standards were updated for the first time in 40 years. We've learned a lot in the past 40 years that was not incorporated into the regulations. Standards like 70E, 70E is now upgraded every 3 years. Best practices, we can go to a workshop every year, and then just understanding and knowledge with the people around us. If you want to prevent injuries, and compliance isn't your only goal, you need to make sure that not only you're compliant, but that you know what the best practices are out there that can prevent injuries. So as part of your culture, as part of what you accept, are you sending people out there to seek out best practices? Are you able to articulate to your line management why the cost of implementing a best practice is worthwhile? And managers, are you willing to listen when somebody comes back and says, you know what, I went to Idaho National Lab, and here's what they do with their linemen. I think it's a great idea, but it's going to cost a little bit. What do you think? If your answer is, are we required to do it by regulations? That's probably not a good sign. A sign of a strong electrical safety culture is the ability to operate in this area instead of arguing over this. That's a strong litmus test right there. And I'll tell you, at Berkeley Lab, we're not that great at it yet. Some examples of best practices. So these are best practices that are not required by law. And yet, guess what? You're already doing most of these because you understand what the hazards are. You already have a defined two-person rule. You have defined PPE for switching activities where there's arc flash hazards. You have defined thresholds for capacitor stored energy hazards. You have, I'm not sure about the fourth one. You have the arc resistant switchgear. And we've talked a little bit about the last one. So these are examples of best practices. Why would we want to wait for these to be in a regulation before we implement them? Okay, integrating the drivers into your electrical safety program. How do you do that? One, you need to make sure that it's in alignment with your corporate objectives. So if you're a program manager and you're speaking a completely different language from your COO, it's not really going to work. So you got to adopt the same language. Some ways to do that maybe is figure out what your mantra is, and I'll show you an example. It'll be easier. So at DOE here, we have ISM, Integrated Safety Management. One of the things we did at Berkeley is for our electrical workers, we actually took the ISM process, we picked it apart, we put in specific steps related to how to do electrical work for each part of ISM. And we trained to that. Every training we go to for electrical safety, we start with ISM, and we make people regurgitate, tell me what the steps are, and what does that mean for your electrical work. And we're constantly bombarding them with, what's the scope of work? What are the hazards? How do you know? What do you do next? What's the next step in ISM? And we train that, we teach them. So that's an example of alignment. The other thing you need to do is communicating your objectives. Does your electrical safety program have a mission statement? Does it have an objective? Do people know what it is? What are we trying to do? If our objective is only compliance, I'm telling you that's not a program. Nobody's going to care about compliance. Here's an example. The number one goal of every electrical safety program should be this: prevent electrical-related injuries. And that needs to be made crystal clear. Yes, we have a duty for assurance. We need to demonstrate compliance to standards, but that's sort of down here. We need to figure out how to prevent injuries. The regulations that are currently in existence, I'll tell you this, they are not enough for the types of hazards that you are faced with at DOE labs. There's no regulation out there that talks about a 10,000 volt capacitor or talks about those high voltage cages that you go in with your ground sticks. There's nothing like that. You need to educate the population about electrical hazards and promote a vibrant electrical safety culture. That needs to be explicit. People need to be looking at the electrical safety culture. Is it healthy? Are we looking for the right things? Understanding and accounting for human error. All right, it had the desired effect. I know I tend to be monotone, so I put a funny slide up here to get your attention towards the end here. How do we treat mistakes? How do we react to near misses? Is it a bunch of knee-jerk reactions? Does it kind of go all over the place? Is it a big flail mode? It's kind of important to understand what's a good way to react to incidents. We need to understand that humans fail, and it's normal. But we have to factor that into our systems, both our engineered systems and our processes and policies. We need to make sure that we're promoting learning when we make mistakes. We don't blame individuals. Remember, the beliefs drive behaviors. If somebody has an unsafe behavior, we need to find out what their unsafe belief is first. Why did they think that was okay? It's not because they're stupid. I'll tell you what, this is probably the highest IQ average auditorium I've ever had the privilege to present to. But no system can be truly human-proof. So we need to find out in our incident investigations, what were people thinking? What was the contextual rationale for their decisions? And how do we build processes that are robust enough to guide them in the right direction? There's something called a skill-based performance mode. And most electrical work is done in this mode, where we rely on somebody who's qualified, skilled, has experience, they know what they're doing. I'll tell you, electrical workers, we're kind of a different breed. If you're an electrical worker and you try to tell me what to do, I don't really hear it. And pretty much most electrical workers in here are like that. We rely on our experience, our technical knowledge, and we use that to make proper decisions. But the skill-based performance mode has two failure modes that are quite common. One is inattention, and the other one is this perceived reduction in risk. So when we look at our processes and we look at our incidents, we need to dig in these areas. Inattention, execution errors, emissions triggered by human variability, that's just your basic process error type thing. A lot of times people don't recognize a change in work scope and they veer outside of their lotto safe zone or something like that. Perceived reduction in risk. This is one that's hugely related or correlated to experience. You have so much education experience that you think the activity is not that risky. Whereas in fact, it's quite hazardous. And if something does go wrong, there could be serious consequences. So we call that unintentional blindness. Here's an example. This happened in England. We had a wind turbine technician sustain an arc flash injury. He was in the hospital for 2 weeks. And it was on, basically he had the system locked out, but only partially, and he ended up taking off a cover that he wasn't supposed to and went in there without doing test before touch. So it was an error. The immediate reaction by management, fire him. He did something he wasn't supposed to do. It was against our policy. But when we did the root cause analysis, we found out that there were several things going on. First off, they had already disciplined 2 other people that had been off duty for the last 3 months. So now there are only 2 guys splitting all the work for all these wind turbines. He was doing 60-hour work weeks. He didn't get any weekends. This was a Friday afternoon job at 2 o'clock. This turbine had been down for like months. The senior management called him on Friday afternoon and said, "You better get this turbine up and running this afternoon or else." Just a cell phone call out in the field. What they didn't know is this guy's mom just got diagnosed with terminal cancer. He'd known this for a few weeks and he hadn't had the opportunity to go visit her. So that was on his mind. He was trying to get the turbine up. he was trying to go home and see his mom. She died 2 weeks later. So when we do our root cause investigations, we need to find out what people's beliefs were and how they made these mistakes. And again, as managers, our systems, our supervision, the way we ask questions needs to be robust enough to prevent this. Okay, summary and conclusions, and I have a little video to show you. The main point of this whole presentation is there's a strong link between your electrical safety culture and electrical injuries. I'm not here to say that you have a bad electrical safety culture. That is not the message. In fact, from what I've seen, you have a good electrical safety culture. What I'm here to say is just beating on people with compliance is not necessarily the best way to change people's beliefs. Because if you really want to prevent injuries, you got to find out what the beliefs are. You got to talk to people. You got to find out what they're really thinking. If you have a poor culture, you'll have unsound beliefs, unsafe behavior, and that will eventually lead to injuries. If you have a good culture, you'll have sound beliefs, safe behavior, and injury prevention. 4 ways to approach it, just in summary. Management must own the safety culture. That is a management responsibility. You don't get to walk away without this. As an organization, all the SMEs in here, you have a duty to go out there and find out what the best practices are that match the work that you do here and incorporate it into your daily work. Electrical Safety Program Manager, Mike. You need to monitor and improve your culture. Where are we at today? How do we even monitor it? And last, in your incident investigations, look at human performance. Learn from human error. Don't beat people up. Try to figure out how to make your systems more robust. So these are just ways to approach cultural improvement. Finally, what unsafe conditions and behavior do you accept today? And will you continue to accept them tomorrow? This is something that I would just kind of want everybody to ask themselves. So again, this is a presentation that we gave in Reno. This wasn't just made for Argonne National Lab. We gave this as a challenge, sort of nationally, to look at what changing the culture means and how we get to improve things for tomorrow. Now I want to show you a little video. So before I start it, the person on the screen was the CEO at the time of this wind turbine company I used to work for. And when I started off there, we did not have an electrical safety program at all. This little clip, I wasn't even there. This was sort of an international meeting of the top 400 managers of the company. It lasted for about a week, and it just took about 5 minutes or so to talk about electrical safety, but it was pretty powerful. And this is an example of what management ownership of culture looks like and how we can change the culture. So let's see if I can get this to play.
But now comes a main point this morning. Our biggest safety challenge going forward is that the injuries we see are much worse than the ones we have seen and will probably be also more severe. What I'm talking about here is electrical safety. And as you will see in a few minutes, electrical injuries are quite different from bruises and cuts. Not that I in any way want to downplay those, of course not. But injuries from carelessness with electrical safety either injuries you severely or it downright kills you. And it's not my intention in any way to scare the hell out of you, sorry for the language, but that's how it is. So I want to make sure that in this room we are all on the same level when it comes to these potentially very critical injuries. But no matter how we look at it, bottom line is that these new safety measures are here to stay. And yes, I know they do take some investments on our part for equipment, training, and so on. To be more precise, approximately 4 million euros, and that is involving some 71 full-time employees. Please save 4 million euros on your human memory card up here this morning, as I will put them into perspective in just a second. And talking about time and money, I'm also fully aware that some of our service colleagues might be a bit worried with regards to the time consumption involved. And that is a valid point, as the measures, the checklist, and the so on involved to avoid electrical injuries and accidents are, of course, by nature, pretty detailed. But so be it. Safety first. The first picture shows a nacelle, or what used to be a nacelle. Remember the amount saved on your human memory card? I hope so, because had the safety measures been in place here, we would have saved not 4, but 5 million euros. 5 million euros, meaning that our entire investment across the organization would be home safe. But do we really have to do all this? And do the customers really care? Yes and yes. Yes, because we want no injuries. The health and safety of our colleagues is a number one priority for all of us, period. And yes, our customers certainly care a lot about safety. In fact, they put emphasis on safety like never before. We know that because we ask them. And believe me, as far as customers' expectation in this field is concerned, we only seen the tip of the iceberg. The next few pictures will give you a better background for understanding why I expect, or maybe let me be more direct, demand that no one fools around with electrical safety, or with any other form of safety for that matter. So ladies and gentlemen, I feel certain that these photos will leave some impressions with you, I hope, and that we need no more to talk about safety today, but that this is now clearly embedded in your human brain.
I probably should have warned you about the gross pictures. Sorry. So the person had an accent because they're Danish. That was in 2011. Remember the presentation I showed you from Berkeley Lab listing all those incidents? I had done the same thing with this company, and I put numbers up next to them. 1, 2, 3. Except that that company, because they didn't have any program at all, it wasn't near misses we were having. You saw those pictures. It was real serious injuries over and over and over. And when we got to 10, I told management, time's running out. When we got to 14, about 2 months after this, this video was shot, we had a fatality. So don't let time run out. It takes a while to change this stuff. It's difficult. It's all kinds of policies. It gets really complicated and complex, and people are asking about the meaning of every little word. So you're not going to be able to change everything overnight. Just get started. The last thing I have, you may have seen this kind of floating around. If you're an electrical worker, I just want you to remember this. This is how we kicked off our campaign worldwide back in 2011, because most countries don't even have regulations driving electrical safety. If you don't do this, if you don't do anything else, at least do this. You lock out before you work, and you test before you touch. No electrician invented yet has a remote sensing ability for voltage. You don't know until you touch it. That's why we give you meters. That's why we give you ground sticks. That's your last line of defense, regardless of whatever policy we come up with, whatever program, whatever communication. Please do this. Go home safe to your families. And I think I have plenty of time for questions. Thank you.
Questions, Mark?
I know it's lunchtime. Yes, sir.
I know you mentioned you showed the
incidents at Berkeley since 2012. Have you seen a reduction then in the past year or two, or how's it been as of late?
Yes, so our program actually rolled out in 2015. It took us about a year to get everything written up, the training ready to go. We really put a big emphasis on this right off the bat in all of our communication. We also had to sort of tackle the whole idea of who's designated as qualified electrical workers, who's not. And pretty much we've only had like 3 shocks related to cord and plug grabbing the prongs. We haven't quite figured out how to solve that. And we've had 1 capacitor short circuit burn, kind of like what you had. In that case, it was a researcher going to the back of a cabinet. They didn't know there was capacitance. They were just kind of removing a rack-mounted piece of equipment. The cable fell over and hit an exposed diode. And we had about 2.5 kilojoules at 160 volts discharge near his hand, so he had a little bit of a burn. So we're not out of all the woods yet, that's for sure.
So I had one for you. You talked about, regulation and compliance is not enough. The department has guides and handbooks and things that exist sort of on top of the regulations. So how do those exist in the pantheon of things that you look at for your program?
If it helps, do it. That's how I see it. Regulations are very strict and they're not very lenient, and you don't get a lot of flexibility. When you talk to people that sit on these technical committees that write the regulations, if there's a sentence that's vague in a regulation, it's intentionally vague. There's 2 reasons for it. Sometimes they just don't agree, so they write something that's sort of in between. But most of the time, they want to give you the leeway to implement something that works for you. So when it's not required, take advantage of that to define something that works for you. Don't ignore that opportunity.
Okay, well then with that, let's thank our speaker one more time.